Hi there, in this video I'm going to talk about the Cartesian equation of a plane. So I'm going to talk about the Cartesian equation of a plane. The word Cartesian means one equation in terms of x, y and z only. Okay, so in the previous video I gave you a result to work out the scalar product equation of the plane. So now I'm going to show you how to convert between the two. Okay, so remember in the previous video, so the scalar product equation of a plane, so that had the result r dot n is equal to capital P, and remember capital P is a dot n. Okay, so that we've seen that result in the previous video. So if I replace the capital P by a dot n, we're going to have r dot n equals a dot n. Okay, so let me quickly discuss these terms. So in the previous video, remember, n is a vector perpendicular to the plane. So n is a normal vector perpendicular to the plane. A is the position vector of a fixed point on your plane. And remember, r is the position vector of any point on your plane. Okay, so let me show you how to convert the scalar product equation of the plane into Cartesian form. Okay, so let me give you the method. So method to convert into Cartesian form. So remember, the word Cartesian means one equation in terms of x, y and z. Okay, so if you're given r dot n is equal to p, so if your equation is in scalar product form, okay, so in this case, if you have the fixed point vector on your plane A, if that is, say, a1i plus a2j plus a3k, and supposing you're given the normal vector n, so the normal vector for your plane, and if that is given by n1i plus n2j plus n3k, okay, in step number one, so let me call this step number one. Step number one is you let r, so remember r is the position vector of any point on your plane, let r be xi plus yj plus zk. Okay, so remember, going back, r is the position vector of any point on your plane. Okay, these two vectors for a and n should be given. And in step number two, what you need to do is you need to put r equaling xi plus yj plus zk into the scalar product equation, which I'm going to call star. Okay, so I'm going to put r that is equal to xi plus yj plus zk into star. So let me write that down. So put r xi plus yj plus zk into star, and by doing this we're going to have, so if we put it into star, we're going to have xi plus yj plus zk, so that is r, dotted with n is n1i plus n2j plus n3k, and that is equal to a given, that is a1i plus a2j plus a3k, dotted with n is n1i plus n2j plus n3k. Okay, so I hope you can see this. I squeezed it just about over here. Okay, so that is r dot n equaling a dot n. Okay, so I substituted into star the scalar product equation of the plane. And when we go through the scalar product on both sides, so on the left hand side, multiplying the components and adding, so we should have x times n1, so n1x, plus n2 times y, n2y, plus n3 times z, n3z. So remember, when you take the scalar product, you multiply the coefficients of I, j, and k, and then add. And that's equal to doing the same on the right hand side. So if you multiply the coefficients of I, you get a1 times n1, a1, n1, plus multiplying the j coefficients, a2 times n2, a2, n2, plus multiplying the k coefficients, a3 times n3, a3, n3. Okay? So this equation over here is what we call the Cartesian equation of the plane. So remember, it's one equation involving x, y, and z only. So this equation that we're ending up with is the Cartesian equation of the plane. And over here, the equation that I called star, remember, that is the scalar product equation. So scalar product equation of the plane, Cartesian equation of the plane. Okay? So here's the method in order to convert the scalar product into the Cartesian equation of the plane. And that completes the video. So in the next video, I'm going to go through the method in order to convert some equations in scalar product form into Cartesian form. So I hope to see you then. Thank you.